Hello there, Mr. Sutton here, bringing you this IM3 Honors 1-4 Extra Practice number 4 solutions on inverse functions. So our strategy for all these problems on which we're finding the inverse is going to be pretty much the same. First, we're going to double check and make sure it has an inverse, just by making sure that we're not dealing with even powers or absolute value or anything like that that would fail the horizontal line test. And then, if it does have an inverse, we will switch the input and output variables and isolate the output variable. And for the output variable, I'm going to use y most of the time, unless y is the input variable, in which case I'll use z. So you'll see as we go along. This first function now doesn't have any of those weird inverse breaking sorts of functions, so I'll switch the input and output. So I'm going to rewrite this as b equals 3/5 y minus 7. And now I'm just going to get y by itself. So let me add 7 to the other side. That's b plus 7 over there. And in order to get y by itself here, I'm going to multiply by the reciprocal of 3/5, which is 5/3. And I'll just leave this stuff in a parentheses over here. So I can write y equals 5/3 parentheses b plus 7. But instead of writing y equals, I'm going to write b inverse, or actually f inverse of b, equals 5/3 b plus 7. This f inverse used to be the y right here, but we put it back in there just to be very specific about what we've just found, which is the inverse function for f. Here we go with number 2. This one looks like it'll pass the horizontal line test. If you reduce everything here, this is really just a line when you get down to it. So let me start by replacing rearranging things so that we have z equals negative 10 minus 5y over 3. Again, just input and output are switching here. And then if I multiply both sides by 3, that would be another good step to get y by itself. So 3z over there. Add 10 to both sides, so that's 3z plus 10. And then divide both sides by negative 5. So I'll write this as f inverse of z equals 3z plus 10 over negative 5. For this function, definitely has an inverse. This is just a line here. So let me go ahead and switch the input and output. I'll write this as k equals 4y plus 8. And then if I subtract 8 and divide by 4, that'll get y by itself. So I'll write f inverse of k equals k minus 8 over 4. For number 4, we have a cubic function, which this particular cubic function, at least, will pass the horizontal line test. There's no even powers in here. So let me switch input and output. I'll write this as q equals y minus 6 quantity cubed. Then I have to cube root both sides to get y by itself. So we have cube root of q over there. And then just add 6 to the other side. So we have f inverse of q equals cube root of q minus 6, or plus 6 rather. For this one, this is another cubic function that's going to pass the horizontal line test. No even powers to worry about. So let's switch input and output. We have r equals 7 times y plus 9 quantity cubed. Next up, before I can cube root things, I need to divide by this 7, so r over 7. And now I can cube root both sides, like I did on the last problem. So we have y plus 9 equaling cube root of r over 7. And then finally subtract 9 from the other side. So f inverse of r is going to equal cube root of r over 7 minus 9. For this one, we have a very basic line. This is going to pass the horizontal line test. So switching input and output, we have n equals 8y. And then just divide by 8 to get y by itself. So I can immediately write f inverse of n equals n over 8. For this problem, we've got ourselves a line. So it'll have an inverse. Let's switch input and output. So w equals 11 over 7 y minus 8. And then if I add 8 and multiply by the reciprocal of 11 over 7, so 7 over 11 times w plus 8, that's what I can set f inverse of w equal to. For this problem, this is a little bit trickier because y is the input variable now, and I've been using that as kind of my stand-in for the output variable. So I'm going to use z as my output variable this time around. So let me rewrite this. We have y equals 7 minus 9z over 11. And now to find the inverse, I'm just going to isolate z. There's nothing magical about having y represented. It's just a good output variable most of the time, but not this time. So let's multiply both sides by 11, so 11y, and then subtract the 7 to get this negative 9z alone, and then divide by the negative 9. So we have f inverse of y equals 11y minus 7 over negative 9. For number 9, we've got a line in mx plus b form. This will definitely pass the horizontal line test. So switching input and output, I'll write x equals 2y plus 3. Subtract the 3, and then to get y by itself, divide by 2. So f inverse of x equals x minus 3 over 2. For number 10, we have an even power here. So this is going to fail the horizontal line test. Since we have the even power, that means this is going to have no inverse, and we don't have to do our dance of switching input and output or the rest of it. Now, I believe on the worksheet, this one, they actually gave an inverse for their answers, but they're mistaken. There is no inverse for this. For number 11, this is another one where the worksheet was wrong and tried to find the inverse. However, we have an even power here. So this is another one that's going to have no inverse, fails the horizontal line test. And now for our final boss battle. This one is kind of underwhelming. This is just a line. We can switch input and output then. S equals negative 7y. And then just divide by negative 7. So f inverse of s equals negative s over 7. So that's it for this one. Till next time, Mr. Sutton signing off.